Okay, so this is 1.3, and we're now going to start looking at limits and what limits are. So a function f, just as usual, f of x, has a limit at L, and that's as x approaches a, which can be written as this right here. Okay, so that's the limit as x goes to a, and this is of f of x, and this whole thing will equal L. And this is only provided that the values of f of x get closer and closer on both sides of the function, okay, of the a value. So let me just, okay, so now a limit. This limit can be approached, like we said, it has to work for both sides of the a value. So this limit, it can be approached from the right and the left. This is called a right-hand limit and a left-hand limit. Now, this limit, it can actually only exist if all three things are true. So let me just grab the blue pen. And so if all three things are true, these three things have to be that the limit as x approaches a, and I'm going to put a little minus sign here, that means from the left. So as the limit as x approaches a from the left of f of x, this has to exist, meaning it equals a number, meaning it equals infinity. The second thing is that the limit as x goes to a, I'm going to put a little plus sign, and this means from the right. And so as the limit as x approaches a from the right of f of x, it also has to exist. And then the final third thing is that the limit as x goes to a from the left of f of x must equal the limit as x goes to a from the right of f of x. So as 1 exists, 2 exists, 3 is that those two things must equal, and this means that that limit does in fact exist. So just like before, we were saying if the limit exists, well, now we want to be able to say if the limit is continuous or not. So a function f of x is continuous. And that's at a number x equals a, just like before. Here we had the limit as x goes to a from the left, from the right. So here, the f of x is continuous at that number if the following are all true. All right? So this is that f of a is defined. If it's not defined, you can right away say it's not continuous. Also, if the limit as x goes to a of f of x exists, and the limit as x goes to a of f of x equals a, f of a, sorry. And if those are equal, and if all of these three things are true, then we can say that it's continuous. Now, what does a continuous function mean? Yes, it means that all these things must be true. However, it also means that a continuous function, it must be continuous for all x values. For example, if that says x ER or x belongs to all real numbers. And so what that actually means is that you can actually put your pen on the graph, and if you can draw your pen along the entire graph without lifting your pencil or your pen, then that means that the graph is continuous. If you have to lift it off of the graph because there's a hole there or a gap there, this is said to be discontinuous, or it has a discontinuity. And so this is a way that you can tell from graphing as opposed to doing more the algebraic way, which is these three ways. You can tell it just by putting your pencil on the graph and being able to lift it up. So that is all for this lesson, and Monkman is out.